Hello everyone and welcome to another lecture video here in Earth Science. So in this particular video, I'll be discussing to you the Earth's materials. So we have the first one is the mineral. No? So nating pag-usapan ay kung ano ba yung mga minerals, guys. Okay? So minerals are described as the building blocks of rocks. No? Pag may nagsama mo yung iba't ibang klase ng mineral, so you will come up with a rock. So that is they are building blocks of rocks, and we use them every day. Okay, so, we use them in the medicine that we take. We use them to cure our diseases or conditions, and also sa cooking, sa culinary, we use them, and also in the construction and agricultural industry. So in the agriculture, we use them as fertilizers for the crops, and for the industries, the cement, for example, and other materials for construction. Some of them are, merong minerals. Okay? Sige. So, we also use them sa fashion. Nagiging accessories sila, nagiging jewelries na ginagamit ng mga fashionista syempre, at yung may mga mahilig na magsuot ng mga alahas. Okay? So we have here mineralogy is the study of minerals, and included dito yung pagsa-study sa distribution, identification, at saka pag-examine sa properties of minerals. Okay? So in order for an unknown substance to be considered as mineral, it must meet 5 requirements. Okay? So for a substance or for an object to be considered as mineral, dapat ma-meet niya yung 5 na requirements. So ano-ano yun? We have, dapat naturally occurring siya, inorganic, solid, has a definite chemical composition, and must have an ordered internal structure, or the arrangement of the atoms dapat ordered siya. So when we say naturally occurring, guys, ibig sabihin it is not produced by people, or it is not an artificial na object. Okay? So it must not a product of any factory or robot. So dapat naturally occurring siya sa nature, syempre. So steel is not considered as mineral because it is an alloy produced by people, just like the galvanized steel, which is also an alloy of zinc and iron, and stainless steel, which is also an alloy of nickel and iron. So all of those man-made na materials, solid na materials, na produce man ng mga factories, so they are not considered as minerals, okay, unless naturally occurring siya. And then, in order for an object or for a substance to be considered mineral, dapat inorganic. Okay, so it must be inorganic, which means that the substance is not made by an organism aside from humans. It must not be produced by a living organism, may that be a microorganism, a plant, or another form of animal. So hindi dapat siya na-produce ng living organism. So just like the wood, the pearls, they are not considered as minerals kasi nga they are produced by living organisms. Just like for example, for pearls, siya ay pinoproduce ng certain species of mollusk or ng bivalves oyster, pearl oysters, so it cannot be considered as mineral. Okay? Next, we have solid. So it must be solid at STP, or standard temperature and pressure. Okay, so what is our standard temperature, guys? So the standard temperature in physics and chemistry is negative 273 degrees Celsius or 273 Kelvin. Meron pang decimal yon, na round off lang sa whole number. And the pressure is 1 atm or 1 atmospheric pressure. So that object must be solid at STP in order for it to be considered as mineral. Kaya yung water is not considered mineral because it is liquid. But we have mineral water, di ba? Okay, so ano ba yung nagpapamineral sa mineral water? When we say mineral water, it refers to the component of the mineral water. Okay, so not the water alone, but the minerals within the water, or the minerals that were mixed with the water in order for it to become mineral water. So mineral water has minerals, just like calcium, sodium, potassium. So these minerals help our body retain water during dehydration, especially pag na-diarrhea ka or nagkaroon ka ng lagnat. So, most of the time, yung nire-recommend ng doctor or ng ating mga parents ay uminom ka ng Gatorade or Hydrate in order to retain, i-preserve yung water sa katawan mo para hindi ka ma-dehydrate. Preserve or retain yung water sa body mo. So, yan. And a mineral must also have a definite chemical composition. So, dalawang bagay lang yung kailangan nating tandaan dito, guys. So, it must have consistency. Okay? Consistency in terms of what? In terms of the elemental component. For example, here, yung sodium chloride, merong sodium and chlorine. So, all forms of salt has sodium and chlorine. So, consistent siya. Consistent and elemental component. Yung elements within that molecule or within that mineral dapat consistent siya in all forms, no? Lahat ng salt merong sodium at saka chlorine. And take note pa, no, yung isa pang dapat nating tandaan when talking about definite chemical composition, dapat meron siyang consistent ratio yung mga chemicals niya. Say for example, sodium and chlorine, the ratio is always 1:1, not 1:2. So all forms of salt, merong ratio na 1:1 yung sodium and chlorine niya. Another example is calcite. Calcite. Yung chemical formula for calcite is CaCO3 or calcium carbonate. So this one can be obtained sa mga limestones, no? Ito yung minerals na bumubuo sa mga limestones, or in local dialect, ito ay tinatawag natin na igang, no? Limestones that can be found sa mga lugar na malapit sa dagat or sa mga mountainous area sa gilid ng bundok, yung calcite or calcium carbonate, yung limestones. So the ratio is always 1:1:3. So that is 1 calcium, 1 carbon, 3 oxygen. So calcium carbonate. So all forms of calcite na makikita sa buong mundo ay merong ganitong ratio at merong ganitong mga chemicals. Calcium, carbon, or meron ganitong elements, no? Elemental components. Calcium, carbon, at saka oxygen. So again, guys, ano yung tatandaan natin when talking about definite chemical composition? You have the ratio and the elemental composition niya. So dapat yung dalawang variable na yun ay consistent in order for that substance to be considered as mineral. And then next, guys, you have ordered internal structure, or the arrangement of the atoms within a mineral. So it must be arranged, or they must be arranged in a systematic and repeating pattern. Just like here, the halite, which is composed of equal ratio of sodium and chlorine atoms arranged in cubic pattern. So meron tayong iba't ibang shape ng kung paano i-arrange yung mga atoms, guys. Meron tayong tetrahedral, meron parang pyramid, parang triangular, meron ding spherical, at meron din tayong mga irregular na arrangement. So say for example, this is the only difference between graphite and diamond. Graphite and diamond, they are described as pure carbon. So ibig sabihin yung atoms nila, they are all carbon. Kaso nga lang, bakit mas mahal yung diamond? Bakit mas expensive siya, mas matibay kaysa sa graphite? So saan ba yung graphite makikita, guys? So ang graphite makikita sa lid ng inyong pencil, or at the tip of your pencil. The one that you are using sa pag-write ng mga notes, no? Yan. So graphite yan, no? Hindi yan uling. Merong mga charcoal pen, pero yung karamihan graphite, no? graphite yan. So bakit mas ano no, mas yung diamond mas mahal? That is because of the way carbon atoms are arranged in a diamond. Okay? Mas iba. Kung makikita nyo guys, medyo loose yung arrangement ng molecules ng carbon dito sa graphite, while dito very intact. So the strength or the hardness of diamond is mas high yung measurement niya kaysa sa graphite. So makikita medyo merong mga broken na bonds between the atoms of the carbon dito sa graphite. So that's it when we are talking about internal or ordered internal structure. So we have here the most abundant na mga elements in our Earth's crusts. You have the silicon and oxygen, and they are the dominant components of our minerals. Yung pinakamalaking group ng minerals natin, which is the silicate, yan, no? It is composed of silicon and oxygen. Yung chemical compound, when you combine oxygen and silicon, you will come up with a silica. This is a compound also known as silicon dioxide. No? Yung common name niya is silica. The chemical name is silicon dioxide. Silicon dioxide. Or yung chemical formula niya is SiO2. So that's it. So that is the primary rock forming and mineral forming compound, no, sa ating nature, sa crusts. So almost 75% ng ating crust ay binubuo ng silicon at saka oxygen. So here we have followed by aluminum, iron, calcium, magnesium, traces ng magnesium, sodium for the salt or the halite, and potassium and other elements. Pero yung mga pinaka-abundant talaga, you have the oxygen and silicon. Now let's go to the physical properties. So how important are physical properties, no, in the identification of minerals? Paano sila naging mas or paano sila, or ano yung kanilang importance, no? What are the significance of this or how significant are these physical properties sa identity or sa identification ng minerals, guys? So sila yung nagiging natin, guys, parang clue on determining the exact identity of an unknown minerals. So that is for investigation or survey purposes. Say for example, we want to study the mineral content of that particular area. So ginagamit natin yung iba't ibang physical at chemical properties nila para i-describe kung ano ba yung unknown na mineral na nakita natin, kung meron man. So that's it, no? Physical properties. Yung una nating physical property ng mineral dito ay yung hardness. Yan. So again, guys, yung physical properties and chemical properties, they are used to describe the mineral and at the same time identify the mineral. Not only to describe but to identify the mineral. So number one physical property of mineral that we are going to tackle is the hardness, or it is the comparative property, and so is indicated by a harder mineral being able to scratch a softer one. So the scale that we use in measuring the hardness of mineral is what we call the Mohs scale. So presents the varying degrees of hardness, which runs from 1 to 10, soft to hard. So this is the this is the Mohs scale, guys. So we start with the top and then we end with the diamond. So far the hardest mineral is diamond. But according to some of the articles that I've read, hindi na yung diamond yung strongest material, guys, sa earth. Meron ng mga bagong mas matibay kaysa sa diamond. Kaso hindi sila mineral, parang sila, no? Parang artificially made. So hindi sila ma-consider as mineral. So we have here, yung Mohs scale, guys, ay pinangalan sa, siyempre, si inventor nito na si Friedrich Mohs. Okay? So however, the method of comparing hardness has been used as far as 300 BC pa, no? Na-mention ito ni Theophrastus sa kanyang Theatis on Stones na study, no? Or na article. Yan. So, kumbaga, in-improve lang ni Friedrich Mohs yung method na na-formulate talaga ni Theophrastus during the ancient time, no? The classical time. So, in-improve lang ni Friedrich Mohs. So, pinangalan kay Friedrich Mohs. So, ano ba yung mga included na reference na minerals sa Mohs scale, guys? So, yung again, na-mention na kanina, yung number 1, that is the talc. And then, or talc muna, gypsum, then calcite, fluorite, apatite, feldspar, quartz, topaz, corundum, at saka yung pinakamatibay dyan ay yung diamond. So, we use these reference minerals para i-determine yung hardness ng isang hindi pa natin alam na mineral. So, say for example, meron kang unknown mineral and you try to, again, that is a comparative property and you test it using Mohs scale. For example, this is our unknown mineral. Hindi natin alam kung ano yung measurement ng kanyang hardness. So we try to test it through Mohs scale. So in the level 1, which is the talc, hindi siya na-scratch. So there is no damage in the unknown mineral. And then we scratch it to the next reference mineral, which is the calcite. Calcite. Dito kanina. Yan, calcite gypsum pala. Gypsum. Yan. So, gypsum. So, hindi pa rin siya na-scratch. And then, try natin siya na mag-increase. So, number 3. And then, na-scratch siya ng reference natin na number 3. So, ibig sabihin, yung kanyang hardness ay, yung range niya is from 2 to 3. No? Yung hardness niya. 2 to 3. And then, you will try to find for those known na minerals na merong range ng hardness na 2 to 3. And then, usually, sinasummarize na lang natin yung kanyang hardness sa dito. No? Nire-refer natin sa harder mineral being able to scratch the softer one. So, usually that one. Pero yung umpisa dyan, guys, sa pag-measure ng hardness is dinedetermine muna natin yung range. So, the range is from the last na softest na mineral na nag-scratch sa kanya or wala na test sa kanya, and then doon sa pinaka-minimum na mineral na naka-scratch sa kanya or yung unang mineral. So that is the range muna. And then we try to retest it and repeat at saka ma-obtain na natin yung mas accurate na measurement na kanyang hardness, which is for example here the 3. Yeah. So that is how we summarize the measurement of hardness. So, first muna is i-determine muna yung range and then i-base natin doon sa harder mineral pag paulit-ulit na nasa range lang tayo. Yan. Or yung pag-determine natin ng parang nagka-error siya. So, usually we refer na lang to the harder na mineral na naka-scratch sa kanya. So, that is how we solve for the Mohs scale. The disadvantage of Mohs scale, guys, is that it's less accurate when compared to the digital ones. We are now currently using a digital or computerized measuring device para ma-measure yung Mohs scale. Before eto manual to, guys, na device ni Friedrich Mohs, no. Manual ito. So right now, because of improvement in technology, innovations, meron na tayo na-develop ng mga devices or computer devices na pwede nating magamit sa pag-measure accurately ng hardness ng isang mineral. So that's it, guys. That's how we measure hardness. Next, we have the cleavage. Yan. So cleavage refers to the tendency of minerals to break along definite smooth plane. So say for example, if there is a mineral and break siya along smooth plane, take note, guys, of the requirement. No? There is a requirement which is definite smooth plane. So if a mineral ay na-break siya along a smooth plane, no? Ibig sabihin nito, guys, is perfect yung kanyang cleavage. Perfect cleavage. And then pag na-obtain natin yung ganitong result, i-compare natin siya doon sa mga minerals na known na alam na natin ng mga minerals na merong perfect cleavage. For example, meron kang unknown mineral, hindi mo alam no, kung ano yung identity ng mineral na yan. So, the only way to know the identity of mineral is to determine its physical properties. So, gaya nito sa cleavage, perfect yung kanyang cleavage, ibig sabihin, doon ka magre-refer or magko-compare sa mga minerals na known na, alam na, no, na documented na merong perfect na cleavage. So, hanapin mo doon sa mga minerals na yon na ang merong perfect na cleavage na mineral. So, baka yung unknown na mineral mo ay nandun siya. Okay? And then, meron naman tayong mga imperfect na cleavage. Ibig sabihin, nag-break siya, hindi smooth plane. No? Medyo rough, irregular shape yung na-produce na chunks or pieces. So that is imperfect, no? Imperfect cleavage. So you can describe cleavage in terms of its perfection. No? Pag nag-break siya along definite definite smooth plane, so perfect siya. Pag hindi, imperfect. Okay? So that's it. Next, we have the color. So color refers to the property of reflecting light on one or more wavelengths. So yes, color refers to the superficial, guys. In number 3, we're talking about the superficial color of a mineral. Say for example, if this is our mineral, red, the color is red. So all of the spectrum or wavelengths of light are being absorbed by this mineral except for the red color. So that's how we describe that's how we describe the color of a mineral. Yan. Okay? So that's it. So if you will be asked if the color of the mineral is blue, if the color of the mineral is blue, so what wavelengths of light or what colors of the visible spectrum are being absorbed and ano yung colors na kanyang nire-reflect. For example, this one, blue siya. Yan. So, lahat ng colors ng spectrum, except for blue, ay ina-absorb. Yung blue lang yung nire-reflect. So, that's why yung appearance niya sa ating eyes ay blue siya. Okay? So, because of impurities, guys, yung superficial color of minerals, it is, the superficial color of minerals is not a reliable basis for identifying minerals. Kasi nga meron tayong tatawag na impurities. So, yung impurities nakaka-cause ng drastic changes in the color of some minerals. And, siyempre, parang misleading siya. Magiging ma-mislead tayo, no? So, kung ano ba yung totoong identity ng mineral pag nag-base tayo sa superficial color lang. So, instead of superficial color, yung superficial color kasi, guys, nagbabari siya. So, instead of superficial color, we refer to the streak, the fourth property. Yan. So, for streak, it refers to the color of the powder of mineral. So, hindi yung superficial niya lang, kundi yung loob, yung internal structure niya. Yan. So, pag ni-rub natin in an unglazed porcelain, yung mineral, we will obtain the powder. So, yung powder indicates the true color or will show the true color of the mineral, which is not it is not varying, no? It's not varying, and of course that means na consistent siya. So mas reliable siya, no? Mas reliable yung streak when compared to the superficial color of a mineral. So, instead of the superficial color, you use na lang streak. So, you rub mo siya in an unglazed porcelain, yung mineral, in order to obtain the color of its powder. And you compare it to the standards. Yan. So, ano yung mga minerals na may ganitong streak? So, dyan mo malalaman kung ano ba yung exact na. Hindi naman exact, no? Parang deductive lang kasi yung pagdedetermine natin ng identity ng mineral. So, here, streak, no? So streak is more reliable na basis for the color of mineral kaysa sa doon sa superficial na color niya lang. Number 5, we have here the luster or refers to the appearance of mineral surface in reflected light. So, ibig sabihin, ito yung property. This is the physical property of mineral, which refers to its interaction with light. So, there are two, no, major luster. But I added one here, guys. No? So, we have metallic luster, which is a polished metal. It looks like a polished metal. And non-metallic luster, the appearance may be of varying luster likened to the material. So, for metallic luster, the light is being reflected. Kaya nagiging shining, shimmering, splendid siya. The light is being reflected. While for non-metallic naman, guys, that is either absorbed or di kaya ay refracted. Refracted. So, pag refracted, ibig sabihin nag-bend lang yung light. Pag reflected, ibig sabihin nag-bounce back yung light. Say for example, here we have two smooth planes. For reflection, that is, eto siya. Ito yung direction ng light. Reflection, nag-bounce back siya. For refraction, inabsorb siya, tapos na-bend. Na-bend siya. So, that is metallic and non-metallic luster. Okay? For metallic, reflected. For non-metallic, that is binibend, no? Refracted yung light. Refracted. Okay? Refracted siya. Refracted. So, yan, no? Meron tayong iba't ibang klase ng luster, guys. Siyempre, you have here the metallic. Yan. So, metallic reflectivity, just like the galena and pyrite. And then, ito yung added, guys, no? Yung extra. Submetallic, slightly less than metallic reflectivity, just like the magnetite. So, yung metallic, guys, nagsashine siya talaga, no? Sparkly na luster, no? Sparkly na luster. Yung submetallic, hindi masyado. Meron siyang nire-reflect na amount of light, pero yung iba ina-absorb niya rin. And then we have also the non-metallic. So we have ilan bang non-metallic? 6, no? Yan. For the first one, the adamantine, that is the luster of diamond. So we have here the cerussite and the anglesite are examples of minerals which have adamantine luster. And then number 2, you have the vitreous, the luster of the broken glass. Broken glass example is the quartz. Number 3 is the pearly, iridescent, or pearl-like, katulad ng talc and apophyllite. So the appearance of pearly, guys, is glossy. This somehow, nagsashine siya. Glossy. Nagsashine siya, no? Glossy, but at the same time, smooth yung kanyang pag-shine, no? Yan. So, glossy and parang dirty white yung kanyang color, guys. Kasi parang pearl, dirty white, no? Yung kanyang color, or cream na white, no? Parang ganun yung kanyang color. So, for adamantine, that is the luster of diamond. Vitreous, luster of broken glass. Pearly, medyo glossy or dirty white yung color, yung appearance. And then we have also the resinous or the luster of resin. Yung appearance niya, guys, parang powder or parang gum, chewing gum, no? Yan. Gum or plastic. Parang ganyan yung kanyang appearance, guys. Okay. Luster, yung resinous na luster ay parang gum or pastel color, kumbaga. Plastic color, powdered, parang ganun yung kanyang appearance ng resinous, guys. Example of that is the sphalerite and sulfur, and another one is the amber. I don't know if you're familiar with that, no? Amber. Yan. So, ito yung mga legitimate na mineral, right? And then you have the sulfur. Gum or plastic, parang ganun yung kanyang appearance, just like this one. Then we have also the silky, a soft light shown by fibrous material, just like the gypsum and the chrysolite. If you're going to observe the surface of a mineral which has a silky luster, you will find parallel lines, guys. No? Meron kang ma-observe dyan na parang mga parallel lines or fibers sa surface. Just like this one. No? Yan, meron parang mga parallel lines dyan sa kanyang surface. So, these are fibers. No? Fibers of minerals na nandyan siya. So, the luster is silky pag ganun yung appearance. Then, we have also the dull or earthy. So, it is very, medyo siya, dark. And then, ina-absorb talaga yung mga light. Wavelengths ng light. Kaya, hindi siya masyadong nagre-reflect ng light. Ina-absorb niya. For example, here we have the kidney ore variety of hematite. Actually, hematite, ang color niya originally is red. But because of impurities, meron tayo ditong kidney ore variety. Yeah. So, medyo dark yung variety na ito, guys. For the luster. Okay? So, that's it for this video. And then, on the part 2 of our lecture, I'll be discussing to you the next 5 properties, physical properties of the mineral, and I will also discuss to you the other special properties, and at the same time yung mga groups ng minerals natin. So maraming salamat.